Hey. So, hey, does this look similar to something you have in front of you?
No.
Yeah.
Oh, well, that's not good. Okay, so anyone but Ian who can see, yes, it does look similar to what's in front of you. And Ian, it's not a comment about your glasses, but apparently your inability to discern what's in front of you versus what is on the board.
Ooh.
Roasted.
Riley.
Hey, thank you.
You put Mr. Titus there. I don't know what the heck he
Ooh.
said.
I wasn't going rap guy like this, okay?
No,
So our first one we're gonna do is we're gonna do a radical review. Okay. So let's first just look at simplifying radicals. So this is going a lot of what was on the board, but we're going to start out even just the first step of that. So our first thing is what we want to check for with radicals is we want to check for perfect square factors. Okay, we're going to say that radical, like a square root of 8, is going to be equal to 2 square roots being multiplied together. We're going to say it's equal to 2 square roots being multiplied together. So is there a perfect square? Notice how the first 15 perfect squares are listed here for us. That's kind of convenient, okay? Is there a factor of this that is also a perfect square? 4. So we can say that the square root of 8 is equal to the square root of 4 times the square root of what other number? 2, because normal 8 is equal to 4, normal 4 times normal 2. So the square root of 8 is equal to the square root of 4 times the square root of 2. Now the reason we look for perfect square factors, the reason we want to look for a factor that's a perfect square is because we can say the square root of 4 is equal to what normal number? 2. Okay. We can say the square root of 4 is equal to just normal 2. So do we have it in the square root anymore? No, because it's a normal number. But what happened to this one? Do we know the square root of 2? Is it a perfect square? No. So we just continue to write it as a square root of 2. And what was this square root of 4 and this square root of 2 doing? What operation? Multiplying. So what's this regular 2, which is the same thing as square root of 4, and the square root of 2 doing now? Multiplying together. But we can't push them together anymore. Just like you couldn't push together A and B together anymore. They're as close together as they can get. Okay. I mean, I already have a bet one against you, but whatever. And so our final answer will be 2 times the square root of 2, because there's no more math that we can do to make this simpler. We don't want to approximate what the square root of 2 is. We don't want to approximate what the square root of 2 is for this. This is called simplest radical form. We say simplest because this is as simple as it can get with our simplifying process, and it's radical form because it still has a radical in it. Okay? Square root of 108. Now we might not know off the top of our head what square roots can go, what perfect squares can go into that, but we want to look for our biggest perfect square factor. We want to look for our biggest perfect square factor. So I think 100 might go into it. Does 100? No. Okay. How could we have some help on this? We could use a calculator, right? Okay. How could you check if a number is a factor of this? Okay. Could you take? Okay. So could we take 108 divided by 9 to find out it goes into it 12 times? Yeah, we could. Okay. So we could call square root of 108 square root of 9 and the square root of 12 being multiplied together. We could call it that. Goodness gracious.
I did. I said 9.
Okay.
And you said
9.
well. I said, well, it's not that.
What is the square root of 9?
3.
3. So did that help us? Yeah. Is there any perfect square factor in the square root of 12 though? Because we might be able to look at 4 times
3.
Yeah, so 3 times the square root of 4 times the square root of 3 again. Now what's the square root of 4?
2.
Regular 2. So what are we going to do with this 3 and the regular 2?
Multiply.
Multiply, because all of these operations are
Shoot,
multiplying.
I put it on the wrong thing.
Okay. What is 3 times 2?
6.
Can we simplify the square root of 3 anymore?
No.
No. 6 times the square root of 3 is our answer. Hey, what if pro tip, if you found out that you could simplify again after you went through it once, we did not get the biggest perfect square. You still got the right answer. We had to go through the process again. Something you could do is you could take a calculator, and I could take 108,
Yoga.
and you could start off with what number might it be reasonable to start off with testing for perfect squares for 108?
26.
Maybe 100 and below. Because could it be a number bigger than that number? No, 100 is At least not a whole number factor. Okay? It could be a decimal factor. It actually is, but irregardless. So take 108 divided by 100. Nope, doesn't work. You can keep going down the list and keep dividing. And no, which one did you say might work? 36. So if you take 108 divided by 36, how many times does it go into it? 3. So you don't have to write this, but this is an extra thing that some of you might want to write it, some of you might not. Either way is okay. So this could be the square root of 36 times the square root of 3. And what is the square root of 36? 6. That was so much faster. If we find the biggest perfect square,
Sorry.
then
Wait,
it's going to be so much faster.
I was listening, but I stopped.
So you say 108. What's the first not perfect square smaller than that? 100. So you go here, you start at 100, and you take 108 divided by 100. Doesn't work. 108 divided by 81. Doesn't work. Doesn't work. Doesn't work. 108 divided by 36. It's 3. So you end up taking the square root of 36 times the square root of 3.
Could you just like take a really small number like 108 divided by 2 or 108 divided by 3 and just go from there?
Sure.
That sounds like a lot.
That would work.
That's what I can't. I'm sorry.
I'm sorry.
I hate myself. I'm sorry. I'm Aubrey.
You sound like Tatum.
Don't shake his hand, Aubrey.
Aubrey,
Okay, other questions on B?
you all.
I want you guys to do C by yourself. I mean, C by
Did
yourself.
it.
Okay, I can do this, man. I can. No, this one's too complicated.
It's easy.
You know, wait.
You had it. Did I get it?
No, you're not.
You want to show it? I am.
Thank you.
Oh, wait, no, I didn't. Hang on.
Hang it on.
Oh, okay. You've never heard him say that before in school? Well.
Left is a square. Yep.
So much circles to it.
What's up?
Oh, multiply.
Wait, what'd you get?
I'm surprised this class is not supposed to be big.
We played Just Dance in the Revival.
Oh, wait, you're, no, that's what we're talking about. Yeah, RIP and peace. Give them
I used to lay in the classes like this.
In here?
Yeah.
Oh, yeah. Alright,
That's why you.
so, is there a perfect square that goes into the square root of 125 evenly?
Yes.
Yeah, what number? 25.
And five.
That goes into it, a factor. So 4 times the square root of 25, don't forget this 4, times the square root of 5. What is the square root of 25 equal to? Just 5. 4 times 5 times the square root of 5, which is
20 times the square.
Yes, not most people.
questions on this one. Alright. So moving on to D then. Moving on to D. Square root of 3 times the square root of 2. If we multiply radicals, we're gonna multiply just like we would multiply like we're going to 2. So we multiply the 3 times the 2 here. We multiply what's underneath radicals with what is also with words. We multiply what's underneath the radical also with what's underneath the radical. So square root of 3 times the square root of 2 would be equal to the square root of 6.
Why couldn't you just say you multiply the two numbers inside the radical?
Yeah.
Yeah.
Like you You made that extremely
It was a
complicated.
struggle.
and it didn't need to
So
be.
word
It was a struggle, Bus.
Word bomb is just like
Yeah.
Riley.
I'm not proud of that one.
I'm not proud of that one. I'm Adrian. Hey.
So is this just the reverse process of what we were doing?
Kind of.
Yeah, it's really just a reverse process of what we were doing. Because before what we said was the square root of 1 8 was equal to the square root of 9 to the square root of 12. Now we're just going the reverse way and multiplying them together.
Wait, so basically on E you could figure it out even more.
Okay, what could we do again on the E?
So 7 times 3 is 21.
Yep, 7 times 3 is 21.
Then 5 times 5 is 25.
So it's the square root of 25.
Yeah, but the square root of 25 is 5. So 5 times 21 is 105.
Very
Oh
good.
my gosh, Ian is so smart.
Ian, did you get some hairs cut?
No.
Does it look
Do
like
you have the numbers that are on the inside of the
I think
radical?
I got a few.
They're both the
I
same.
grew some
Can't you
hairs.
just do it on the like the numbers on the outside of the radical just keep going there? Or do you have to always?
No, you don't have to go through this process. If you already know it's 21 times 5, you can. Yep. Jake was asking, hey, square root of 5 times the square root of 5, that'll always end up being normal 5. The square root of 5 times the square root of 5 will always end up being normal 5. Because if you take the square root of 5 times the square root of 5, you get the square root of 25. And so you'll always get the square root of that, which is a normal number.
Like if you do 2 plus 2 divided by 2.
Doesn't that like happen for all of them?
Yeah, so if you take the square root of any number times the square root of that same number, it'll be
Okay,
a
so
normal number.
basically you just have to do like 3 and 7 and then you automatically get 5.
Yep, 1 times 5. Yep, that's what Jake was asking. On F, hey, is this one a lot like our warm-up? Yeah, it's a lot like our warm-up where we had 4 times the square root of 3 squared. So what this means mathematically, squaring means multiplying the same thing by itself. So it's this many, it's 2 of these being multiplied together. So it's 9 times the square root of 2 times 9 times the square root of 2. So what's this going to be?
81.
81 times 2. Because we know the square root of 2 times the square root of 2 will be normal 2. It goes to the square root of 4, which goes to normal 2.
162.
And it goes to 162.
Mental math, you know. It helps when you have a
One way we can
test.
think about this, guys, one way we can think about this, I like the way that Daniel wrote on the board here for the square root of 3 squared like that. Or for us, on this one, it would have been like this. It would have been 9 squared, and square root of 2 squared. The square and the square root undo each other. They're what we call inverse operations. So just like addition and subtraction undo each other, multiplication and division undo each other, they're called inverse operations, opposite operations. So the square root here, and the square are inverse operations. They're opposite operations. So they undo each other. Whenever we square a square root, or vice versa, you get whatever inside. Okay. Do we feel a little more comfortable with radicals now?
Yes.
Hey, good. We're going to use them. It's way more radical. It's pretty radical. Oh, we're not done with triangles yet.
I hate triangles.
Yay!
That's the spirit.
Do you know triangles used to be my favorite shape and then I
I love my
Just wait, wait. You'll think of it more. Just wait till you get to the pentagon. You have to learn apexes. Oh, that's going to be your favorite.
Actually, squares are my favorite shape because when you know, like when you're in like elementary school, they're like get in a circle. I was the kid who was like, well, what if I like squares more? Like I was that.
Not even a little surprised. Hey, a right triangle. A right triangle is a triangle with one right angle, right? You know that?
Yes.
A right angle has a measure of what? 90 degrees, okay? Does anybody know what we call A and B in the right triangle? Legs. So A is a leg, B is a leg. Write this in. What do we call C?
The
Hypotenuse.
That's right.
Wow, you're spot on.
Now, how can we always spot which one's supposed to be the hypotenuse?
The one that's
The one.
across from the 90 degree.
I heard two things there. It's along a side, and it's across from the 90-degree angle. It's across from the right angle. I'm gonna write that. Okay, Aubrey, what were you saying?
Isn't it usually also the line that's like diagonal? Because the 90 degree
Yeah,
is generally on the.
but that's not always true. That's for a graph. That's usually going to be the way it these are going to be off the graph a lot. Okay, so this is across from the right angle.
I don't know how to spell
Ten.
Everything's on the board.
Are we supposed to fill in the blank?
What?
The blank.
There's a lot of that.
Hey, we'll get there.
That
Just to the
is
first
you.
part.
I was just reading.
We're just asking questions, calm down, you're at cheapers.
Buckets, okay. Did everybody get this part down in the orange? Okay, make sure we have it down. Okay, this is
You're thinking
hypotenuse
it's bothering.
is,
You have like a parenthesis on it.
oh yeah, that's okay.
It's actually, it's across.
Yeah.
It's a really fun cross.
Okay. Hey, we have this Pythagorean theorem. We talked about this, okay? Only true for right triangles. So in a right triangle, if the legs have lengths A and B, the length of the legs are A and B, like it is here, and the hypotenuse has length C, then we know that A squared plus B squared will equal C squared. Okay, we know that to be true, right? We've talked about that before, right? We talked about that. Okay. Hey, I want to show you something that just kind of demonstrates why that's true.
Alright.
So if you guys can listen up, please. Oh, hey, hi, good. I'm Mr. Costle. Hey, ladies and gentlemen, listen up, please. Okay. So, shh. We have a triangle here, right? Okay, we have a triangle. I'm moving it around a bit. We have a triangle. What's coming off of each of these sides of the triangle? Square. Hey, notice how we called it A squared, B squared, and C squared? So that's literally a square. They're literally squares. It's a squared distance here because the area of a square is two sides multiplied together. And so if one of the sides of the square is C here, then the other side of another side of the square will also be C. So the area will be C squared. So how the Pythagorean theorem was formed was actually by making these squares that come off of it and saying, hey, no matter what size we make this, because notice I'm changing some of the sides of the hypotenuse here, or if I go to here, I can change the sides of the A and B, the legs. Notice how C stays constant, but if we move it here,
Oh my gosh!
if we move it over here, B squared is a lot smaller than A squared now, right? But because it's still a right triangle, C squared is still the same. Because it still has to equal those. So as long as C squared equals 41.12, that's going to be the case. The others will adjust to fit it, regardless of what these other two angles and the lengths of the sides are. And if I adjust this size, the length of the hypotenuse, A squared and B squared have to adjust to fit it. Okay. Let's go to the next page. What? Can you do that with 3D objects? That was Pythagorean theorem. Hey guys, Kaylee has a question, but I can't hear her because we're a little loud.
So are we gonna learn? Cause like, okay, so I took this test, right? And it had like this cube thing, right? And then it was like like a dot right here, and I made a corner like across the cube like that. It was like you have like a cube, like a cube, you know? And it went from one vertex to the opposite side of the thing on like the top. Are we gonna learn like that?
Without actually knowing what else was asking about, that's what we're talking about. Because there's a lot of other things we could talk about.
Honestly,
Yeah, I was like,
Right on.
we have to learn the opposite.
Example 1. Find the length of the hypotenuse of the right triangle. Do this one on your own. Yes.
Hey,
What was my example for?
guys.
That's not right.
Yeah, I was like, this
Mr. Carlson's office horse or something.
office.
Yeah.
What?
Horse.
I've never heard that phrase.
You've never heard that phrase
It's not a common one.
But
Make sure to find what the length is, not what the squared length is.
Dude, I'm gonna be done with all my English by the end of the year. I'm so happy. I'm not gonna take any hard classes. I guess I'm taking biology too.
He was very on your side.
Could be other ways to find the diagonal products of short. Hey, let's talk about this one. Who thinks they have it? Okay, Kayla, you wanna come and do this?
My brain.
Yeah,
No, you don't know.
I'm proud of you.
You have it on black.
I'm so proud of you, Mr. Constantly. Proud father of the month.
Mr. Consul. I would like to, so I put down on the list for Mr. Work, but can I go to Morosic first to turn something in? So let me send a copy to Morosic.
Maybe.
Not even snow, I think like freeze my brain. He wants to die. Must be really fine. Nope.
Hey, boys, stop! Kaylee's going to explain this one. Thank you, Kaylee.
So you take the two legs and then you find the thingy.
You square them?
Yeah, that's the word. And then you get 25 and 144, and then you add them together, and you get 169. And then you take the square root thing of that, and you get 13.
Thank you.
Because if we square root both sides, guys, if we square root both sides from here, if we square root a square, that undoes it because those are inverse operations. So then we just get C. And C is a perfect square. 169 is a perfect square, so it is exactly 13. Not approximately like we had on our distances for last test, but it's exactly.
Are they all gonna be exact?
Nope.
No.
You think I did that nice?
I was hoping.
Okay.
At the end of class, can you put
Oh,
what
no,
class
that's
I'm gonna be in for math next year?
Just
I already have that. Because I can.
Oh. No, I was seriously wondering the same thing. I was like, oh, okay, question on this example, guys. Okay, hey, right below that, what's it say? Pythagorean triple. What's that mean? So, for the Pythagorean theorem, we have certain whole numbers that are always going to be, that will always work out a certain way. So they'll always work out in certain whole numbers. Now, not every time that you have a whole number that works out like a perfect square, like Faith was asking, not every time it's a perfect square, like square 169 is square root of 13. But sometimes when they are, it'll be because of a Pythagorean triple. It's a set of three positive integers that form a right triangle. So these lengths will form a right triangle. So if you have a triangle with these lengths, it'll always form a right triangle. Yes.
Okay, so do you know you're wrong if your x is smaller than your
Are you on this one?
no?
Okay, what are you talking about?
Like, okay, like if your hypotenuse length that you find, like say I did it, okay, well I know that. Like, so if I get 5, 12, and like 7 as my length for my hypotenuse,
7 is room for hypotenuse 8.
okay,
So 7
so
because it has to be
does
the
it
big
have
side.
to be the longest?
Has to be
Okay.
the longest side. Yep.
That was my question.
So for these Pythagorean triples, I want you to put in the star. They can be multiples of this. It can be multiples of this. That means you can multiply the whole thing. You can multiply the whole triple. You can multiply the whole triple. Okay, so you can have a Pythagorean. You can have a right triangle with lengths 3, 4, and 5. You can also have it with lengths of double this, where it's 6, 8, and 10. Or tripled, 9, 12, 15. 4 times 4, 12, 16, 20. And so on and so forth. And all of these multiples can be triple. Or all these multiples, all these triples, you can multiply them to find other ones. If we look at our previous triangle here, actually, an example 1 is right above this for you guys. This ended up being 5, 12, 13. So the lengths of this triangle ended up being 5, 12, and 13. Is that one of our triples that we have?
Maybe.
Yeah, it is. So if we recognize that as a Pythagorean triple, and we know 5, 12, and 13 is a triple, and we're looking for the hypotenuse, and we know 5 and 12, we automatically know this will always be 13. We automatically know that it will always be 13 if we know 5 and 12. Or if you're given 5 and 13, and you're looking for a leg, it has to be 12. You can always know that the Pythagorean triple can be like a shortcut for you to help find it. If you don't want to do the theorem and you recognize it. Now, our most common ones are these 4, but inside of these first 2 are by far the most common. 3, 4, 5, 5, 12, 13 are by far the most common. Yes.
I have a question. So, like, example 1, you're trying to find the hypotenuse, which is labeled x. Do you want us to always say that your final answer is c equals, or do you want it to be x?
That was a good question. Riley asked, hey, on a given 1, it has to find the length of the triangle, and it was labeled as x was the hypotenuse. And then, but we changed it to c. Does it matter? I would prefer your final answer just be x equals 13, just because that's what it was asked of us. But if we want to put it into our Pythagorean theorem as c, and then just
then
circle
write x.
13 or something, or write x equals 13, that'd be awesome. Good question. Okay. Let's try example 2 here. Yeah, that's a good question. Example 2, find x and write your answer in simplest radical form. Write your answer in our simplest radical form. So I want you guys to go ahead and try that.
Wait, so for 10, like for example 2, since it's 10 and 6 squared, would it be a equals 6 squared plus b squared plus 10 squared? Alright, can you figure that out?
Are you just in geometry? Yeah, I'm alphabet 2, correct?
Right,
Do you want to see that for me?
Only if you have it done.
What? You're able to do it. Oh, I'll get it done.
I hope that.
Watch, done. You know Wizards of Waverly Place? Remember that show? We're in Wizards. I wish I had some toggles because if I'm too lazy.
Everybody's
This
having a
is
lot of
just
trouble with it.
That show is so cool.
Really?
Because like
Algebra
you
2
look
is my
upstairs
favorite.
like that one like hidden
Well, I like
room.
algebra.
That was so good. It's like they're on spy room, whatever it's called.
Yeah.
That is not words.
It's a signature.
I could have done that myself.
Yeah, bet.
I could have, and it's literally lying.
So be careful if you're set up on the first triangle.
You know what I'm? Hey, wait! I think you have to sign this honor teacher's one too.
Yeah, I'm right about that. Yeah.
Oh yeah, same here. I need you to sign it too. While you're over here, I can go. So, how I practice versus. So I have this right now. So it's just plus b squared plus c squared. But I subtract 36 from this side to that side, so b squared is 64.
Yep.
Maybe.
Probably X wasn't a good idea.
Simplest radical form, but yes. You need it to be in simplest radical form.
What does that mean?
Like make sure you get your
So we had to figure out like who. Right? 64.
So you make it all
simplest radical form. But the number's correct otherwise. So now just need simplest radical form.
I'm taking college studies
Oh.
first semester. Yeah, well, because it's supposed to help you with your ACT.
Let's find simplest radical form.
You take your ACT second semester. Okay. Or if you're Jacob, you already take it. But Jacob's gonna have to take it. It's 4 days.
Remember when you check for perfect squares, divide your number by a perfect square to test if it works. If it goes in evenly, it works.
Well,
And then we do earth and environmental.
okay, right? Doesn't go in perfectly, you know?
Do your earth and environmental. Does class teach chem?
Alright, let's talk through the first part of this. So there's two parts to this problem, right?
Yeah,
Because what do we have to do before we find x?
find the side length of the right.
Find this one,
Yeah.
find this altitude, using vocab, vertex of a triangle to the opposite side of the right angle, and altitude. Okay, so we need to find this altitude. What can we call this altitude in the meantime? Sure, you convinced me. So what would we set up in order to find the altitude?
You have to do, oh, I know. Can I say?
Yes, you can.
Okay, so you have to do 10 squared minus 6 squared. And then
Equals
you-
what?
Equals b squared.
Okay, so this setup is really just a variant of our Pythagorean theorem, correct? Okay, so it's like if you had 6 squared plus b squared is equal to 10 squared. And you just move things around to get b by itself, right? B squared by itself. Could we have done that after we had done the squarings too? Yeah, it would work out the same way. So either way you want to do it is fine. Yes, Jacob.
I just have a simpler way to do it.
Bet.
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 What do I want to bet, Mr. Castle?
I don't know, but I have anticipation of what you're gonna bet. Your top 1 month last period.
No. I would die.
That's a
good
one.
Good.
I
like
that
That's
bet.
a solid one.
What about this? What about this?
I'm scared. But what
Aubrey,
is
I'm scared. Aubrey, if you win, Aubrey has to use multiple colors or something for one of these. That she
Oh,
doesn't.
yes,
And
yes,
if and if Aubrey wins,
I can
Jacob
never.
can't use another
for the rest
color
of the year.
Rest of the year. Wow.
Oh,
Okay.
see,
Okay, that's a solid
He is
deal.
confident.
Okay, so looking at Pythagorean triples,
Oh boy.
this is 6, that's
I did
10.
that.
3 times 2 is 6. 5 times 2 is 10. So 4 times 2 has to be 8.
Shoot.
That's what
That's what we
I did.
did.
But then
That's gonna. I'm gonna die. How
I'm
many
gonna
times?
die.
So Jacob, you're gonna choose when that one happens.
Yep.
Okay.
Okay, I'm just in a bunch of because Mr. Costle still doesn't use his, and that's from like first semester.
No, it's just from like a few weeks ago.
Yeah.
Usually
It's
it's 2
like-
weeks ago.
My fingers are angry.
Mr. Costle, it
Yeah.
seems like forever. I hate myself.
No, but there's Durex.
Actually, this one isn't as bad as the one. This isn't as bad as the one that I bet Mr. Costle. So.
So yes, b will equal to 8 by either this method or the Pythagorean triple that Jacob did. Okay.
Definitely.
Good work. I'm like, you made an extreme bet, but I knew he was right, so I'm like, sure, fine. I knew what he was thinking. Like, yeah, he has gonna win.
to make sure it is.
That's what I did.
I saw the look in his eye. I'm like, yeah, he knows what.
It's that is the one that I bet you. So I'm
Is it?
still. No, it's not.
I'm Haley.
I didn't say I.
No, she
You
didn't.
said
She
I'm
I.
still.
She
But
said
I
I
will.
still. She didn't say I.
What? Bet.
No, so Aubrey bet
still
that she wouldn't complain for an entire class period of my choosing about dad jokes.
I didn't say if you're choosing. You came up with that.
No, I
Yeah,
said
but
I
you
get
never
to choose
stated
the
that
name.
you couldn't, so.
That's the bet. So anyway, after we find 8, what do we do now to find x?
Do you, are you
A
doing
squared,
it or not?
8 squared plus 12 squared equals c squared. So 64 plus 144 equals.
Wait, why is it x squared? Oh,
And then it's.
14.42.
Yeah.
Whoa, what are we supposed to do it in though? Simplest
radical
radical form. Make sure we're careful with that one. Kaylee.
Yeah, okay, so, I found that, you can do 16, the square root of 16 and the square root of 30.
good job.
Which ends up being what, Kaylee?
4 times the square root of 13.
Very good, and that is the simplest radical form. Be careful to answer how it asks. If it asks for decimals to a certain number of digits, do that. If it asks for simplest radical form, do that. Be careful. Cuidados, amigos.
What?
El translate, por favor.
Almost
Be careful,
didn't say
friends.
what you said.
Almost a decent.
How do you say what you say?
Almost a decent.
Okay. Example 3.
Oh my god, I love that.
Kelly and I were
Time.
at the Timber restaurant because
No,
also
it's
if you know
Okay. Hey, let's look at this one. If a tree breaks as shown, what is the original height of the tree? Round your answer to the nearest tenth. Hey, so as it shows, what kind of angle do we have here? Right angle, right? That should probably be drawn in so we actually know it. I'm going to give it to you now. Right angle. Okay? Yeah, no problem. Hey, focus back up here, please. How can we find this part of the tree? 'Cause we probably need this part of the tree to find the height of it, right?
So you do like a squared plus b squared equals c squared.
Using what numbers, Josie?
15 and 22.
For where? Which two
So,
letters?
8 is 15
Okay.
squared plus 22 squared equals c squared.
And Josie, could we switch around the 15 squared and the 22 squared?
Yeah.
Sure, yeah,
Why
whatever,
not?
right?
Yeah.
But neither of them could be the C, right?
Yeah.
Yeah, exactly. Okay,
I.
Okay.
Yeah, sure. Why not?
15 squared is,
325.
Here's 10.
22 squared is,
484.
is equal to C squared. When I was in algebra 2 in high school, we had quizzes to memorize the first 25 squares and the first 10 cubes. So they do 1 squared to 25 squared
Yeah.
and 1 through 10 cubes.
For our first.
I love
Yeah, he said
And we
we
all
were-
throw them away.
I didn't
What?
never ended up doing the quiz anyway.
I loved
It was
my
cool.
8th grade math teacher and my 7th
Hey,
grade math teacher.
225 plus 44.
You didn't like
Thank you,
our
Ian.
second grade, we liked our sixth.
For a second, I think.
How do we find C? How do we find C?
You
We're rational things.
Radical. Square root. Rational is a different thing in math.
It equals.
C is approximately, we can round to the nearest tenth, right?
Oh,
C is approximately,
I did
26.6.
26.62705.
Yes,
No,
but
no,
here's
no, it
10.
just said there's 10.
I didn't do that.
are we done?
No.
Oh, wait, we're not?
No. It is.
Why not?
Original height.
Original height?
Yeah.
Why is that going to be different than the original height?
Because that's broken.
That's broken. So you have to put it back on here and add that to this 15, right? Because this is still part of the tree.
I hate everything.
I hate this, man.
I've heard that.
This is bogus.
I feel
So you take
stupid.
15 plus 26.6, be careful what the question is asking, to get 41.6 feet as your original height of the tree to the nearest 10.
I just got guns on me.
Okay, yes, what was it before?
Oh, boom.
I've been lied to.
Okay,
Exactly that. It's been broken for all of eternity.
709, figured it out. Because it's, you're doing it in the nearest 10 here, so you can do 7, you don't have to do 7.
When did it say
Okay.
that that was the
height of it.
I know, but
So we
how do
found
we know?
this length.
How do we know that that 15 is that part of the tree?
Because the
Broken.
drawing is pretty obviously broken right there. A tree breaks as shown. Broken.
Right here.
Okay, Kaylee.
Never mind.
Okay, talk. Tyler.
You have lost my trust.
Okay, good.
We also made that.
How did it go from here
Okay.
to here?
Questions on 3 besides what's been asked?
Black stuff on my paper.
Okay.
That's what she said.
Actually, no, like, you're supposed to saying the color black
Good.
and white is not right.
Haley,
It's a
you remember your
description.
shield though?
Right, yellow.
Sometimes you just got to do it to them. Hey, if we look at this, is this another thing of the Pythagorean theorem? Yeah, the angle shown to be what here? 90 degrees, okay? And I could change these lengths here and show how it's still true, just like I did earlier, right, on the other one. Here's another thing I can do. What if it's an acute triangle now? It's no longer a right triangle. What do we notice about a squared and b squared compared to our c squared?
Not right.
Not right. What's a squared plus b squared now?
It says theorem check is false.
21.61. It's not a right triangle. But what's c squared? So what's greater this time? So before, when it was 90 degrees, they equaled each other, right? A squared plus b squared equaled c squared. Okay, but when we have like, I don't know, 68 degrees, is a squared plus b squared still equal to c squared? No. What is it compared to it? Is it a squared plus b squared is what compared to c squared? It's bigger. Is that going to be that way for any type of acute angle? Let's look. Let's look here, okay? So here's another acute angle, 83. Is a squared plus b squared bigger? Yeah, let's try another acute angle. Somebody give me another acute angle. I heard 13 and 11. Here's 13. Is a squared plus b squared bigger than c squared here? Yeah. Okay, let's try 11. 21.61 and 4.46. 24 and 25, which is funnier.
43.
Notice how
Maybe
these...
like a really small one, like look at that. I don't like it. Yes, thank you.
Okay.
That's usually why they call this.
Go to your next page. Go to the next page, top of this page, and look at that Converse that's in there. Go and read that Converse.
Converse, fun.
Love Converse. Converse are my favorite. Can't be used.
I'm gonna feel you.
Alright, so what's that say there at the top of that next page?
If three sides of the triangle
So this is our converse of the Pythagorean theorem. Converse means we're going the other way around, right? We had the if then from before. Now we're going the other way around. So in a right triangle, if the legs have lengths A, B, and C, or if the legs have A and B, and the hypotenuse is C, then a squared plus b squared is equal to c squared. So our converse, flipping that if and then around, saying if three sides of a triangle satisfy a squared, b squared, and c squared, then the three sides form a right triangle, with a and b being the legs and c being the hypotenuse, of course. So it's just, and it's like we just showed, I just showed you guys, right? And what did we see with when c squared was smaller than a squared and b squared? What kind of triangle was it when a squared and b squared was bigger than c squared? A cube. And so conversely, if c squared is bigger than a squared and b squared, if c squared is bigger than a squared and b squared, then it's going to be obtuse.
No, they were not. I got Rapidate.
Hey, and if we look at this real quick, guys, focus back up, please. Thank you. Give me an obtuse angle. Make this angle obtuse.
180.
No, it has to be less than 180. 112.
179.
What do we notice about a squared plus b squared compared to c squared? It's less than it now. Is that different than what it was when it was at acute angle? Yeah. That's going to be the case no matter what obtuse angle we give, even if it's 179. Okay, isn't that kind of ridiculous? Probably. Okay. One of them can't be 180 because all three angles have to have 180.
That's my favorite thing that you do against your console. When I say that's the best thing I've ever seen in my life, and you go, probably. Like out of everything that drives me crazy, that's the thing that I love. Probably.
Probably is.
Indie soccer, no.
Hey.
Indie soccer.
My
This
man.
desk.
So
That's my
we can
thing.
tell, class.
Or see that.
So we can tell what kind of triangle we have just based upon which doing this a squared plus b squared and comparing it to c squared. We can tell what kind of triangle we have at any moment. Okay? And another thing I want us to look at with this. Stop again. Do I need to take that ruler?
No.
Okay, prove it to me. Another thing we can look at, guys, is did we compare before? Did we compare before how the smaller the side of a triangle, the smaller the angle that was opposite it? Do you guys remember doing that? We compared before. We said, okay, the smaller that the angle is from across from the side, the smaller the side will be. Remember we ordered them from smallest to greatest for angles and then smallest to greatest to sides, and they matched up? Okay, so if all of a sudden we have a 40-degree angle, that side opposite it has to be smaller then, right? So if it's an acute triangle, then this C has to be smaller than it was before. So c squared will be less than a squared plus b squared because the opposite side from this has to be smaller. But if the angle gets bigger, then the opposite side has to be bigger as well. So the c squared is going to get bigger than those. Alright. So on example 4, how can we tell whether this triangle is a right triangle? We don't see any markings for a right angle. Kaylee.
You gotta do this. Well,
Okay, what's the question?
so those equilateral triangles, wouldn't all the angles be six?
Yes.
Okay. My question is like that.
Okay. Aubrey, what can we do?
You can do everything, the a squared plus b squared equals c squared and see if it equals the hypotenuse.
Yeah, and what would be the A and B here? What would be the C?
23.
How do we know 23 is going to be C? Okay.
It's the longest
And
side.
it's also the longest side. So if we were just given these in a list, like 11, 20, and 23, and we weren't given the picture at all, you would know to compare those because 23 is the biggest. So you set up 11 squared plus 20 squared, and you say, is it equal? Like 11 squared plus 20 squared equals 23 squared. You don't get that inflection up in your voice to make sure everyone knows the question.
So that you sound like a 14-year-old.
Exactly.
You're like you're mid-puberty too.
Exactly. So what's 11 squared? 20 squared? 23 squared?
400, 500 something.
529.
Ooh, kill 'em.
521. Does 521 equal 529?
No.
No. What is it compared to 529? Less than or greater?
Less.
Less than. Or excuse me.
That's wrong.
Check it out. Thanks. All right. So
I'm sorry.
there's a lot going on there. Hey, so if a squared plus b squared is less than c squared, if a squared plus b squared is less than c squared, what kind of triangle is this then? No, it's the other way around. A squared plus b squared is less than c squared. It's obtuse.
But that's
Okay.
not what that says right there.
But it is, because here this is a squared plus b squared is less than c squared, which is the same thing
It's
as,
just saying that it's on the. It says c squared first.
these are the same things. So, is this a right triangle? No, but what kind is it? Obtuse. So if you were asked to tell what kind of triangle this is, you would say it's obtuse. Okay? So if your longest side squared is greater than the others, it's going to be obtuse. If your longest side is smaller, squared is smaller, then it's going to be acute. We'll practice this a few more times. Yes, Kaylee.
Oh. Wait, so okay, so a squared plus b squared is b. So c squared has to be bigger than a squared plus b squared for it to be 2.
Correct.
And then I don't know. I was gonna make this question. I had a question, but I forgot. Okay. Wait. Okay.
Wait. No, you can go now.
No. Shh.
So
what's up?
do we have to put the question mark over the thing?
Yeah, we put the question mark over it because at this point, do we know it's equal? No, so we can't say it is. We're saying we're checking if it's equal. That's what this means. This little question mark. Yes.
Okay, so what is it to know if it's like obtuse and acute again?
So there's this little box up here that tells it, but that might be confusing because it goes the other direction. Okay, so if c squared is less than the sum of the other two squares, then it's acute. But if c squared is greater than the sum of the other two squares, it's obtuse. Okay. Let's go to example 5 here. Can segments with lengths of 11.2 inches, 6.5 inches, and 7.1 inches form a triangle? If so, what type? Does anybody remember how we check if they can even form a triangle?
No.
You add the first two. Oh, you add the two smallest to see if they're greater than the largest.
Boom! Man, making me proud there, Evan. Go kill a pancreas for the each of us. You take the two smallest sides, you add them up, and if it's bigger than the third side, it makes a triangle. If it's not bigger, then it can't make a triangle. What are the two smallest sides here?
6.5 and 7.1.
And we compare that to 11.2. Remember when we put this box here before? As we said, we don't know what's going in that box. Remember doing that? Okay. 6.5 plus 7.1 will be 13.6. And what does that compare to 11.2? Greater. So can this make a triangle?
Yeah.
Yes. Okay, so now we need to know what type of triangle. If it's going to be acute, right, or obtuse. How can we check? The converse of the Pythagorean theorem. Okay? So, how do we know what's going to be our supposed C in this and what's going to be our proposed A and B?
So you go with your longest side, so 11.2 is your C.
11.2 will be our C in this. So if we go over here, you guys have a few different places you can work. You can do it right below this, or you can do it to the right of this, still above it. Either way, gave you guys some room here. So you can do 6.5 squared plus 7.1 squared is equal to 11.2 squared. And this can tell us what type of triangle we have. We already know it can form a triangle because the smallest two sides added together before squaring is greater than the third side. So now we can check what type of triangle this is because we know it is.
How many decimal places?
But for this one we can just go all the way up because it's just what's 6.5 times 6.5? 42.25. What's 7.1 times 7.1?
Wait, why would it be 42.25?
It's not. It's what she said. Oh. 6.5 times 6.5.
Oh, I thought we were 7. I was gonna say because it's 4.9. I literally can't be wrong.
So what is 11.2 times itself?
125.44.
Okay. So let's add up these two on the left side, and we'll get what?
It's a cube. It's such a cute guy.
Alright, what do we know about 92.66 compared with 125.44? Less. Okay, so which number was bigger, C squared or A squared or B squared? C squared. So what happens when we have the C squared is bigger than A squared? It's a big boy, it's the obtuse. So can this form a triangle? Yes. If so, what type? Obtuse.
Big boy. I said yeah. Big daddy.
Okay. Let's stop.
Let's keep going further.
Class, we are done with that. Thank you. Okay, let's go to example 6.
I thought it was a obtuse.
This one is obtuse.
Having it acute.
So C squared is bigger than A squared and B squared, so it's obtuse. t squared is bigger than the last one, so also is also
I
2.
know, I just realized.
Hey, on this third one, on example 6, excuse me, on example 6 here, can segments with lengths of 10, 2 times the square root of 41, and 8 form a triangle? If so, what type? Okay, well, we need to know which ones are biggest, right? Of these
Yeah.
three?
I can help you.
You can help us? How can you help us?
Okay, so 2 to the square root of 41. So it'd be 40 to the square root of 40 to the square root of 1 because 1. Right?
But 4 is a bigger square.
You don't add them. We square root of 41 times square root of 1.
Can't we do the square root of?
Look, wait, let me finish it though. Wait, can I go up there and show you what I'm gonna do?
Sure. Okay.
I don't know, I don't
Where
know.
Yeah.
Take the square root of
Because you still have to figure out if it's a triangle first.
Until
Say
it
we don't know if it's a triangle.
Oh, you're only.
Oh, I was doing plus.
That's what I was thinking. Okay, so can we easily compare right now 2 times the square root of 41 with 8 and 10 to see which one's biggest? No, but what happens if we actually figure out what this is approximately? Approximately.
Yes.
You could times it by 2 and see what.
It's approximately 12.8. How'd you figure that out, Evan?
I just multiplied 2 times the square root of 41.
You put it in your calculator, right? You took 2 times the square root of 41 in your calculator, and it turned out approximately 12.8. Okay? So now, which one of these is our biggest side? And which one's the two smallest? This 12.8, this 2 times the square root of 41 is our biggest. So to check to see if this is a triangle at all, what two sides are we going to add together? 8 and 10. And we're going to say, what's this compared to with 2 times the square root of 41, which we say approximates to 12.8. Now, just for comparing purposes right now, we're going to leave this as 12.8, because what's 8 plus 10? And what does that compare to 12.8? Bigger. So does this make a triangle?
Yes.
Yes. Now we need to figure out what type. So how are we going to set this up to figure out what type of triangle it is?
Converse of the.
Josie.
So would you do 10 squared plus 8 squared equals 12.8 squared?
10 squared plus 12 squared by 8 squared equals, okay? And here, we want it to be exact. We want to be very exact here. We're not just kind of comparing to see if it's close.
The 2 and the 41.
We're going to put the actual 2 times the square root of 41 in here and square that. Make sure you put that in parentheses to square it though, okay? And I want you guys to solve from there and tell me what kind of triangle this is. We know it's a triangle, but now tell me what kind.
It is a triangle?
We said it was because the two small sides is bigger than the third side. Oh, okay. Got it. Ah, so what did you do? What is that?
Yeah.
Whatever side.
4, so it's literally going to be 4 times.
We gotta check that. But otherwise, that'd be accurate. Nope.
So what number did I use?
There's no flip.
I didn't do 2 times square root of 41 in that part. You said 12.8. But is this exactly 12.8? So if this was a number, it would be right. It would be a cube that would be correct. But it's not. So you need to add this with a 2 times square root of 41.
Oh, so it's basically 2 times square root.
That makes sense, like we did during our first part. So you square it. So you take 2 times square root of 41 times 2 times square root of 41. Oh, okay.
Oh, they don't.
Okay.
Wait, that's.
No.
Don't you dare hit me.
So using your calculator, it is going bad. I haven't made it.
Careful, calculators go live.
Yeah.
Otherwise, your math is good.
Yeah.
Yeah.
You don't square that.
Oh, wait.
No, because that's the major.
Yeah, it has the two small sides.
Or they don't have it.
I got the same thing.
I have legal on my legal obligation.
It's pretty dank, man.
Don't you dare, Noah. You think like I know where you live. I know where you sleep.
He takes so. Is your name Kai?
You look like a Kai. I know you do, but if you shoot me, I'm not. Oh, every girl you realize that's not true. Noah, don't you dare. Noah, she's lying.
I like this.
We angled it and it's
Yeah,
kind
you
of
can
straight.
touch it. It doesn't go. Oh my god.
It doesn't seem like
Let's say
You know how to create like an all.
What?
Dude, I can't do.
You don't know how to braid. Right here.
Oh no.
That's big section. What?
You guys teach him?
Take a Fraser to set a braid.
I taught myself on my hair.
You were like 8th grade, like you were teaching Cody how to braid.
I taught him how to braid.
Stab my hand. It goes out.
Hey.
What?
You fishtailing, you take.
That's how it works.
Basically, just take one part from this thing.
Have you seen your
I know French.
Yeah.
He's like Bushman in me team.
How Obama?
Hey,
Really
that's so
hard.
It's really not actually. You just like never know to get to the bottom of what. Because you're learning. That's good. Oh, so I don't know our other room or other guys. I do hair.
Did you see her out all live
Okay, class, we're gonna talk about this stuff here. We're gonna talk about this stuff here. This was bringing back the first part that we talked about. This is bringing back our letter F from that radical review. Listen up, listen up. This is bringing back that letter E and F from our radical review earlier at the very beginning of this. 10 squared is 100. 8 squared is 64. And we're saying it's equal to 2 times the square root of 41, all being squared, is the same thing as 4 times 41, correct?
Sure.
Okay, because let's look at the math here on this one again.
Brain.
Class, let's look at the math here on this one. You need to quiet down. Thank you. 2 times the square root of 41, all being squared, is the same thing as it's written twice, being multiplied together. So it's like 2 times the square root of 41 times 2 times the square root of 41. So 2 times 2 is 4. Square root of 41 times the square root of 41. If you don't catch, that's just 41. Babe, what is it? 41. That's being 1,681. And what is the square root of 1,681? 41. If you type that into our calculator, this is going to be normal 41.
I told you, no.
And 4 times 41 is
Well, that's cool. You penciled the word for like how long?
64. It's a gun.
Whoa. Okay. Does this process make sense, or does that still a question for you? Kaylee?
Yeah, I don't understand it because I did something like completely different and I don't know what I did.
Do you want me to look at yours in a second?
Yeah.
Okay, I'll look at it in a second, okay? So table that. Okay, so back to this. 100 plus 64 is 164. We said 4 times 41 is 164. So yes, and what kind of triangle was it, Riley? A right triangle.
Yeah, go
Okay,
team.
that makes more sense than what I was.
Questions on this one besides what was already asked?
No.
Okay.
Can we do homework now? We're just making-
Yeah.
Yeah.
I was
I'm
excited.
excited. Can I just re-punch this?
Right, sure.
I went skating this weekend and I dropped my foot. And then we
Oh my god.
yeah, it was great. And me and Mackenzie were like, oh, we have to get her.
I just hope that it's not,
Are there any dumb things, Mr. Coughlin?
Okay, so there are no don't do's, but what happened? Okay,
It's easy.
calm down. Okay, this was originally. You want to guess how many problems this was originally before I cut it down? This was like 36 problems before I cut it down. How many did I cut it down to? 20. Okay. So this was like 3 pages long. Like a ton of problems.
You cut down the square root of 36.
oh yeah, I made only 6 problems.
Okay. So, but I took off near half. Okay. So I didn't put don't do's on there because I thought about just adding in like a don't do after I adjusted it, just like adding in a random number I didn't want you guys to do, but then it would like go to 3 pages and I couldn't justify killing another tree for that. But I thought about doing that.
Do it.
I thought about like just sneaking in an extra one, being like, hey, don't do this one. Never gonna have you do it, but you know. Yeah, exactly, right? So, when's this gonna be due? Wednesday, my dudes.
Wait, are you sort of writing paper for job?
Yeah, that's